You ever get that feeling like you're just drowning in AI updates?
Hmm.
Every week, maybe even every day, there's some new tool, a new framework.
Oh, absolutely. And another tutorial pops up claiming this is the one, right? The game changer.
Exactly. You watch them, you follow along, you feel like you're keeping up.
Yeah, you spent hours on it. But then when it's time to actually build your thing, your unique idea,
You just freeze.
right.
Yeah.
You can maybe copy paste the tutorial code, but applying it, making it your own, that's where it falls apart.
That feeling, that paralysis.
Yeah.
That's what we're diving into today. It feels like we're just consuming, not building.
Mm-hmm. So what if we could turn the tables? Use the AI itself, the LLMs like Gemini, Claude, to actually guide us,
Guide us from, say, knowing almost nothing about a specific tool.
to having a detailed, ready-to-code plan.
Mhm.
And do it fast, like in a few hours.
Okay, that's the goal. So today we're breaking down this structured three-part system. It's about turning that chaotic learning into real technical ability.
We'll start by looking at why it's so hard, these learning traps that get everyone.
Then walk through the system itself. Research
Refinement.
and fusion. That final step sounds powerful.
It is. It's basically a structured shortcut to getting things done right. Let's get into it.
Okay, so let's unpack that first hurdle. We're generally smart people, right? We can follow instructions. So why is learning something new in AI, like LangChain or some specific API, feel so difficult right now?
Well, the analysis we looked at suggests it's not really about raw intelligence. It's about having a structure for learning, or maybe the lack of one.
Ah, structure. That makes sense. And that leads us to the first big problem you mentioned, the tutorial trap.
Yeah, that's the classic dopamine hit, isn't it? Watch a 30-minute video, type the code.
And it works.
It works, instant success. But what did you really learn? You learned how to copy.
Not how to adapt it, or why it works, or what breaks it.
Exactly. The second you try to modify it for your own use case, it often just collapses because the foundation isn't there.
And the second trap sounds even trickier. The unknown unknowns, things you don't even know you should be asking about.
Right. That's often the gap between, say, a junior dev and a senior engineer. A beginner knows they need to ask something like, how do I build an agent?
Okay, that's a known unknown. You know you need that piece of information.
But the real-time sinks, the dangerous unknown unknowns, are the trade-offs, the subtle but critical choices.
Give me an example. What's a choice that seems small but costs weeks?
Okay. Take the agent concept again. An agent can kind of reason and plan steps, but when should you use that complex agent versus just a simple chain, basically, a fixed sequence of steps?
Oh, I see. Like an agent is maybe more powerful, but potentially slower, more expensive.
Precisely. Agents offer flexibility, like a GPS rerouting for traffic. Chains are rigid, like a printed checklist, maybe faster, cheaper, but less adaptable. That's a huge architectural decision early
A
on.
decision you might not even know you're making if you just follow a tutorial.
Or knowing about things like LCEL, that's the LangChain expression language. It's a specific, efficient way to build those chains. Beginners often don't know to ask about it or how much overhead an agent might add.
That hidden knowledge.
Yeah.
It's like hitting a wall you didn't see.
Yeah, but here's the thing. We can actually prompt the LLMs to surface this stuff for us if we ask in the right way, with the right mindset.
Okay, so knowing these unknown unknowns, how does that really save us significant time down the line?
It stops you from spending weeks building something using fundamentally the wrong approach for your needs. All right, let's talk solution. This three-part system we're discussing, think of it like a funnel.
A funnel.
Okay.
Starting broad and getting more specific.
Exactly. We start wide, gathering the deep knowledge, then we narrow it down into a practical plan, and finally, we connect that plan directly to the actual features we need to build.
So phase one is?
The research phase. This is about getting that foundational understanding and, crucially, figuring out if you're even looking at the right tool for the job.
Got it. Then phase two.
The refinement phase. We take all that research, which might be kind of messy, and distill it into a single, clear, technical document, a plan.
In phase three.
The fusion phase. This is where we bridge the gap. We connect that technical plan directly to the specific product features you outline. What buttons do what, essentially.
Okay. Research, refinement, fusion. Simple enough. But you mentioned a secret weapon here? Specialized prompts.
Yes, this is key. Instead of generic questions, we use prompts that force the AI to adopt specific expert roles.
Like pretending to be different engineers.
Exactly. First, a senior engineer for the deep dive, then a solutions architect to spec it out, And finally, a tech lead to plan the implementation details.
Why are these specialized targeted prompts the key ingredient here? Why does that role-playing make such a difference?
It forces the AI to think beyond just code generation. It has to consider constraints, risks, trade-offs, the stuff real engineers worry about.
Okay, phase one, the deep research prompt. This is where we avoid those wasted weeks, right?
Hopefully. The typical mistake, the fail state, is asking something super generic like, how do I build an email tool with LangChain?
What happens then?
You get generic code snippets, often outdated, maybe insecure, and probably not tailored to your actual needs at all. It's not helpful for building something real.
So the successful approach involves this role-playing. We tell the LLM what exactly?
You tell it. You are a senior AI engineer and a product strategist. You give it a persona with expertise.
And context. Constraints.
Crucial. You define the project constraints up front. I'm a solo developer, medium skill level, building a simple web app, and most importantly, define the goals. It needs to be fast to build, cheap to run, and easy to fix.
Okay, so you set the scene properly, then you demand specific outputs.
Yes, you mandate sections in the report, things like decision factors, the pros and cons of the tool for this project, top alternatives. What else could I use? Like maybe just calling the API directly or Vercel AI SDK?
And critically, real-world problems.
Right. What are the common headaches? Like how hard is debugging complex LangChain chains? Is it stable?
And the final piece you mentioned, the conclusion. Asking for honest advice.
Yeah, you literally tell it, based on these constraints, give me your honest recommendation. Should I actually use this tool for my specific MVP?
So applying this to the example, building that simple marketing email tool, what did the senior engineer AI conclude after this deep research prompt?
It basically said LangChain was likely overkill for such a simple task, given the solo dev and cost constraints. Too complex, potentially harder to debug than necessary for an MVP.
Wow. So what did it recommend?
It suggested pivoting completely, use the Vercel AI SDK, probably with the Claude API directly. Why? Because it's faster to set up for this use case, likely cheaper to run initially, and easier for a single developer to manage.
Okay, hold on. So you spend maybe an hour crafting this prompt and reviewing the output.
Maybe a bit more, but yeah, in that ballpark.
And the AI potentially saves you weeks of struggling with a tool that wasn't the right fit from the start.
That's the idea. Avoiding that initial wrong turn is massive.
So boil it down. What is the main outcome of running this senior engineer prompt effectively?
In about an hour, you avoid committing potentially weeks to a technology that just doesn't fit your project's scale or constraints. Okay, great. So the research phase led us to pivot. We're now focused on the Vercel AI SDK and Next.js. Much better fit.
But now we have this detailed research report. Maybe it's 10 pages long. That's still not code, right?
Yeah.
It's information overload.
Exactly. It's too much to act on directly. We need to refine it, condense it into an actual plan.
Which brings us to phase two, refinement, and a new AI role.
Yep. New prompt, new role. Now we tell the AI, you are a solutions architect.
Okay, what's the solutions architect's job?
The task is specific. Create a concise, practical, technical specification document, a tech spec, and it must focus only on the chosen solution. Vercel AI SDK within a Next.js app.
So we're narrowing the focus right down. What goes into this tech spec?
Key things, like a high-level summary just confirming the final tech choice, then system architecture.
The data flow diagram.
Sort of, yeah. A simple description. User interacts with UI triggers, Next.js API route called keyed API response streams back to the UI. Keep it simple.
What else? Performance. Cost.
Definitely. Expected performance. What's the estimated cost per, say, 1,000 emails generated? What's the expected latency? How quickly will the user see the first word appear? Setting expectations.
And you mentioned a really critical section here, especially for someone working alone.
Yeah.
The TBD list.
Yes. The to be decided section. This is maybe the most valuable part. It's where the AI explicitly lists the things it couldn't figure out from the context, the things that need human decisions before coding starts.
Why is that so important?
Well, honestly, I still wrestle with prompt drift myself sometimes when asking for complex outputs like architecture.
Prompt drift, just meaning the AI kind of forgets the original request halfway through.
Yeah, or it loses focus or makes assumptions. So having it explicitly list the TBDs like, what's the exact prompt structure for Claude? How should we handle API errors gracefully? What's the minimal viable UI? Forces clarity. It becomes a human checklist.
So it flags the ambiguities.
Exactly. It tells you, okay, human, before you write code, you need to decide these specific things.
Why is that TBD section the most valuable part, especially for a lone developer?
It defines the precise design questions that need your human judgment before you actually start typing code. Prevents coding yourself into a corner. Mid-roll sponsor read placeholder.
All right, we have our refined tech spec, we know the architecture, the expected performance, and critically, we have that TBD list, the questions we need to answer. Now what?
Now we move to phase 3, the fusion prompt. This is where the magic happens, integrating the how, the tech spec, with the what, the product features.
Okay, so we need the what first, right? The product features.
Yeah, and this part is usually pretty quick, a human task. Just list the basic requirements as simple bullet points. For our email tool example.
Let me guess. Feature 1, choose email tone. Friendly, formal.
Yeah. Feature 2, input area for key info, product name, target audience.
Feature 3, a generate button.
Right. Feature 4, display the generated email options. Simple as that.
Okay, got the features. Now the fusion prompt. What's the AI's role this time?
Last role change. Now we tell it. You are a tech lead planning the upcoming work.
A tech lead focused on implementation detail.
Exactly. The task is to create a detailed implementation blueprint. This isn't high level anymore. It breaks down each of those features we just listed into specific technical steps.
So for feature 1, choose tone. What would the blueprint specify?
It gets granular, UI parts needed, probably a standard HTML select dropdown, state management. How will the app remember the chosen tone? Maybe using React's useState hook like useState friendly.
Wow, okay. Does it connect to the backend too?
Yes. API backend logic. It would note if this feature directly triggers the API call or if it just sets state that's used later. For the generate button feature, it would specify that's the one calling the API chat route we defined earlier.
And UX details. Little interaction notes.
Crucial UX notes. Things like, the generate button must be disabled while the API call is loading. iLoading is true. This prevents double clicks and manages user expectations.
That level of detail seems intense, but I can see how it maps directly to coding tasks.
It's basically pseudocode for the front-end structure and interaction logic.
So how does this hyper-specific detail in the blueprint actually speed up the coding part?
It pre-solves a ton of common front-end headaches around state management and component interaction before you open your editor. Eliminates those typical integration bugs. Okay. We are almost ready to code. We have the tech spec, the TDDs answered, and the super detailed implementation blueprint. The analysis suggested one tiny final step before the IDE.
Don't tell me another prompt.
No, just 10 minutes with pen and paper, a simple sketch.
A UX sketch based on the blueprint.
Exactly, just draw the basic layout you now have in mind. Box for the tone dropdown, bigger box for the input text area, the generate button, maybe 3 placeholder boxes below for the email results.
The final sanity check. Connecting the blueprint logic back to what the user will actually see and interact with.
Precisely, it solidifies the plan visually.
And then we can finally think about code generation, or actually coding.
Yes. And if you use a coding assistant AI, like Cursor or GitHub Copilot, now you have the ultimate prompt fuel.
You feed it everything we just created.
Pretty much.
Yeah.
Give it the implementation blueprint, maybe a description of that simple UX sketch. Tell it the framework, Next.js app router, the libraries, a Vercel AI SDK, and Anthropic library. The specificity is insane.
Whoa. Okay, stepping back for a second. Imagine applying this system systematically, not just for one tool, but maybe evaluating 10 different APIs or frameworks you need to consider this year.
Right. You could get maybe 80–90% of the initial integration code and architectural decisions mapped out based on informed choices incredibly quickly.
That's leverage learning. True efficiency.
It really is.
But let's address the skepticism. I can hear someone thinking, this sounds slow. 2–3 hours of planning? I could be coding.
It's the classic objection, right? The move fast and break things mantra. But think about it. 2 hours of this structured planning. That could easily save you 2 days of coding down the wrong path.
Or debugging integration issues that the blueprint would have flagged.
Exactly. Choosing the wrong tool up front or getting tangled in state management, that's where the real time gets wasted. This planning is actually the faster path to a working result.
Okay, fair point. What about the other concern? What if the AI's research in phase 1 is just wrong or outdated? AI models hallucinate, they get things wrong.
That's a valid concern, but the AI research isn't meant to be the absolute final word. It's a highly structured starting point.
How so?
It gives you the right keywords and concepts to investigate further. Instead of vaguely Googling AI email tools, you're
Mhm.
now searching for specific comparisons like Vercel AI SDK versus LangChain agent performance trade-offs, or Claude API error handling best practices.
So it focuses your human validation effort,
Yeah.
makes it much more targeted.
Precisely. It shifts your role from aimless searching to informed verification.
Beyond just the speed, the efficiency.
Hmm.
What do you see as the biggest intellectual advantage of using a system like this?
It provides focus. It cuts through the overwhelming noise of possibilities and lets you concentrate on validating specific high probability paths.
Okay, we've walked through the whole process, the research, the refinement, the fusion. It feels like the core idea here isn't just about learning faster.
No, it's more fundamental. It's about redefining mastery. It's not about trying to memorize every single framework that comes out. That's impossible now.
So mastery becomes what? Having a system.
Exactly.
Yeah.
Having a repeatable, scalable process to effectively learn and leverage any new tool that comes your way quickly and efficiently.
The system is the edge. Research to find the right path,
Refinement to make a concrete plan.
and fusion to create that ready-to-code blueprint.
That's the flow.
So, for anyone listening, what's the immediate, actionable step they could take based on this deep dive?
Keep it simple. Pick one technology you've been meaning to learn or one small MVP idea you've had kicking around.
Just one.
Just one. And try running it through these 3 prompt phases. See what the senior engineer says, how the solutions architect refines it, what the tech-led blueprints.
Move past just watching tutorials and try structuring the learning with AI assistance.
Yeah. Get out of the tutorial trap. Use the structure, and maybe think about this. If this system can help avoid picking the wrong tech for a small project, saving you time and money,
What other big, maybe expensive technical decisions are you currently making in your work or even your life?
without applying this kind of structured, almost expert-guided analysis first. Food for thought, out to a row music.